Hello, Challenger. We are here again in this weekly live, and today we're going to be talking about the cloud technologies and the Java technologies that will help you to be more employable in 2025. So, in my career, I kind of struggled to know exactly what I needed to study, and I didn't know how to study correctly. And as a result, I ended up wasting my time studying in the wrong way. And it took me a while until I finally figured out how to acquire real skills. And that's why I'm going to show you what are those important tools and technologies that you need to learn in order to do your best and be highly employable as a Java developer. So the first thing you need to know is the foundation, right? So there are lots of topics here, and I'm going to show you just a moment. So regarding the foundations, we start from the Java core and the JVM mastery. So you need to know about Java 21 at least. And we now have the Java 25 LTS version. If you don't know what's the LTS versions, so basically those are long-term support versions that are supported longer by the Java providers. So like Oracle, Azure, and so on. So I can recommend you to know more about virtual threads, projects. It's not that difficult to understand records and pattern matching, switch enhancements. So those are features that won't take you much long for you to understand. And JVM internals, such as garbage collection. So it's important to know how it works, how the garbage collector works behind the scenes, memory management, just compiler, GraalVM as well. Like reactive programming is not that necessary for the market, but still it's a nice to have. And obviously you need to be good with JUnit 5, test containers, mutation testing. Those are very important for the market nowadays. And algorithms interview preparation. This is crucial, right? So there are lots of topics here. There is a lot on algorithms, right? So let me show you. And so you need to know about big O notation. So you need to know like roughly to estimate what's the performance of your code. You need to know about recursion, divide and conquer algorithm, mathematics, basics, like modular arithmetic, prime numbers. It is structure, so you need to know about arrays, strings, linked lists, stacks, queues, dequeues, hashing. You need to know about hash map, trees, heap, graphs, and try, this set union. And you need to know also about those basic algorithms like sorting and searching, like quicksort, merge sort, graph algorithms like breadth first search, and Dijkstra. You need to know about topological sorting, dynamic programming, memoization, and greedy algorithms, backtracking. And you can see all of those things on LeetCode, right? You can solve those problems there. 2 pointers and sliding window, monotonic stack and queues, and load balancing, consistent hashing. And a key interview insight is that if you really want a job abroad, you need to know about algorithms. Otherwise, like jobs in the US, European Union, or Canada, they won't accept you. Like it's gonna be impossible. So keep in mind that you need to practice algorithms. And how can you practice them? So you can practice them on LeetCode, HackerRank, Codeforces, and you can focus on patterns as well. So you can focus on the sliding window or the 2-pointer pattern. And so you need to be good with algorithms and need to practice, because we don't really use algorithms in our day-to-day job. So keep that in mind. And system design as well, this is very important because these do help you in your day-to-day job, right? So you need to know about scalability, a difference between horizontal versus vertical scaling, reliability, fault tolerance. So you need to know about the client and APIs like REST, message brokers like Kafka, RabbitMQ, microservices versus monolith. So you need to know why a company would use microservice instead of monolith. And the difference is that with the microservices, basically you can deploy this service in an independent way, and whereas like with monolith, you have all your business domain in just one service. So it becomes very challenging to work like in a monolith in a huge team. Like if the team is very big, then it's almost impossible to work in a huge monolith. So you need to know those concepts on the top of your mind. So you need to have an idea of CQRS, event sourcing, saga pattern, service discovery, and circuit breaker, idempotency, idempotency in APIs, database replication, rate limiting and throttling. So obviously I will go very fast here because there is a lot to cover. But if you want to know more, I have the book, Java System Design Interview Challenger. And then I address all of those concepts in the book, and you can go more deep into it. So there is observability, security and compliance. There is a lot. So real world design scenarios, like you need to know how to design simple systems like URL, shortener, Twitter, and like documentation and communication. And the thing is that you need to know about the design to pass an interview for a job abroad, because the companies, they don't want just coders. They want someone, they want a developer who can make a choice about technology, and they want a software engineer who knows how to defend trade-offs. You have to have this capability of explaining, okay, I can use this technology, and that's the trade-off I'm doing. And it's worth it because like this technology has this advantage, the other doesn't. But there is this disadvantage as well. So you need to be able to explain the pros and cons. And like you need to be aware of the modern trends. We briefly discussed that in our previous live. And for example, nowadays, you can see that many Java talks in many conferences, they are talking about Spring AI, integrating LLM features. And the good news is that it's very easy to use Spring AI or LangChain4j. And why is that? It's because it's basically what we've been doing with our microservices. So it's basically, we need to invoke an API from the LLM, and then we're gonna be able to access an LLM tool from our Java application, right? So, and then like your creativity is limited because you can create any application when you use an LLM service like ChatGPT, Llama, or Cloud, whatever you want. And LangChain4j does the same. So basically you can use any of those LLM services, and you can use the power of them, you know. And there's also vector databases like Pinecone, Postgres, and real-world AI use cases like search, summarization, chat-driven interfaces for business-to-business apps. So there's a lot to explore here, and Spring AI is a really good place to start because it's going to be easy. It's going to be easy. And regarding enterprise skills, you need to know about Spring. Like the market, I would say that 90% of the market they are asking Spring Boot. So you need to know about Spring, and GraalVM, not that much, but still it's an important technology to know about. And Spring Cloud, Resilience4j, Spring Security, JWT, like knowing Micronaut and Quarkus is a nice to have. It's very similar to Spring in the end. So if you already know Spring, it's going to be very easy to use Micronaut. And regarding system design and architecture, it's important to know about caching performance. And there are those famous tools like Redis, Hazelcast, and CDN strategies. For API design, we have REST, GraphQL, gRPC, and design patterns, microservices, and we also have DDD, domain-driven design, and regarding professional engineering. So there is a lot here. So nowadays, I think I told you that many times, but the market, they don't look for programmers anymore. They are looking for software engineers. And basically a software engineer is a developer who is able to solve problems and who doesn't depend on knowing all the tools. So basically it's a software engineer is a strong problem solver. So let's talk about some tools here that will make you a better software engineer. Well, primarily it's IntelliJ IDEA. So this is the most famous tool in the market by far. If you want, you can use Eclipse or NetBeans, doesn't really matter. But keep in mind that the tool that is very strong in the market is IntelliJ. Code quality tools like SonarQube, and Checkstyle. And you should know about Maven, Gradle. Like there are some companies who use Gradle, but it's not very popular. And you need to know about Git, very important as well. Like you need to know the basic commands like rebase, squash, hooks, workflows, and you have to have a production mindset as well. So like if you have an incident in production, you need to know how to react. So you need to know how to use logs, metrics, traces, and nowadays we have many tools for that. In microservices, we have Datadog, we have Prometheus and Grafana. So we have many tools that helps us to track down a bug in between, I don't know how many microservices. So debugging microservices is hard. That's why we have those tools and those monitoring tools, which will help us to understand what's going on. And we need to know about rollback and deployment safety, like blue-green deployment, feature flags, canary deployments. This is very important. Like by having this knowledge, you're gonna know how to tackle production errors. And there are also future-proof topics like edge computing and IoT and serverless first architectures. And you can do that with AWS Lambda, quantum safe cryptography awareness. So like we don't know when quantum computing will be popular, and you probably know that if the quantum computing technology is available to everyone, like chances are that many banks would get hacked very quickly, because with quantum computing you can decrypt like the most difficult passwords. That's it. Like nowadays it will take years to decrypt. With quantum computing, you can do that probably in seconds. I don't know. I know it's very fast. So like you have to be aware of that, right? And green software engineering. And you can see it. Like if you go to some conferences, like this topic is getting more and more popular. And like if you see, Java is one of the most efficient coding tools. So you don't need to use a lot of electricity, a lot of electric energy to run Java. Whereas in other programming languages, you use a lot of electricity, right? So this is a topic that is gaining traction. And regarding quality and reliability, you need to know about test automation in all levels like unit, integration, and end-to-end, because only unit tests won't make sure that your application is secure. You need to have at least unit and integration tests, and ideally end-to-end tests. Otherwise, your unit tests, like they don't prove anything. Chaos testing, so that you simulate a system failing. Contract testing for microservices, which means that you're gonna test the API. So you're gonna test the parameters, the output, and performance and load testing with JMeter or Gatling. And this is very popular. Like when you're using microservices, you use those tools. Domain expertise. So fintech for payments, PCI, e-commerce and logistics, healthcare, because the companies will prefer senior developers who are familiar in a specific domain. And regarding resilience and adaptability, it's important to have the ability to quickly onboard into new architectures, right? So when you're joining a new company, the companies will definitely value that in you. So learning new APIs, frameworks, or cloud services, documenting decisions for the future. So what does that mean? It means that, for example, if you make a decision for an architecture, document that developers, when they join the future, they know what's going on. So, and also have the polyglot mindset. Because, like I said, a programmer nowadays is not very valued anymore. So, like, it's better if you have this polyglot mindset, because if you master Java, it's going to be a lot easier to master Python or to master Go or Rust or Kotlin or any of those programming languages. So having this polyglot mindset will definitely help you a lot. And okay, let's continue. So we saw the foundations, the modern trends, enterprise skills, professional engineering. This is very important, guys. Don't underestimate that. To have this software engineer mindset will definitely put you in another level as a software developer. Because like I said, the programmer's profession is dead a long time ago. So if you're still thinking as a programmer, you're getting obsolete. So you have to get out of this mindset. You have to have the software engineer mindset, right? So I think, so the forward looking trends are serverless first architectures, event sourcing, AI assisted development. So nowadays we have GitHub Copilot, and it makes our coding so much faster. And well, it doesn't mean that you're gonna copy the code without knowing what's going on. So basically we're gonna use AI to create code, but we'll still review what's going on. It's not about copying the code and not knowing what's happening there, right? And edge computing with Java. So it's IoT, and it's very important, like soft skills, right? Because, those are a bit harder because it's more difficult to teach soft skills, right? But, regarding soft skills, there are some differentiators. So for example, if you do open source contributions, that will make you stand out as a developer. So the companies won't see you as a normal developer anymore. They're gonna see you as a standout developer. Like open source contribution, it's like very few developers make contributions to open source. So if you do even a small thing like a documentation fixing or a typo fixing or a refactoring, you're gonna be in another level as a developer. Technical blogging or LinkedIn posts, it also shows strong communication skills, and that also puts you in another level as a developer. And I remember when I started writing my blog posts, I got lots of opportunities here in Ireland, and it's because I gained visibility. So basically, I was showing my knowledge, and developers and companies started noticing that I knew my stuff, right? So definitely writing blog posts, it will be a strong foundation for your career. Certifications like AWS or Kubernetes or OCP Java certifications, they are very valuable. And your ability to mentor junior developers, it's highly valued in international teams. So if you have a junior developer who you can mentor your current job, start practicing that, mentor that. We also have critical thinking skills. And what is that? So it's basically your ability to make a decision and talk about the trade-off evaluation. So for example, not every problem needs microservices, Kubernetes, or AI. So the companies, they want a developer who knows how to say no, and basically when the complexity doesn't make sense, right? So microservices are not always the answer. I know that many companies make this mistake, even small companies. And Kubernetes is also an elephant. It's a huge, complicated tool, and sometimes it's not necessary. Like Google uses Kubernetes because it's a huge website, right? It's a huge company. And in this case, it makes sense to use Kubernetes, but in small companies, you don't need to use Kubernetes. That's just an example. Cost awareness, designing services that balance scalability with cloud cost optimization. Risk management, so identifying risks like data compliancy, scalability bottlenecks. So if you are proactive on your critical thinking, that's highly valuable for companies. Collaboration in distributed teams. So like if you're an easy person to work with, that's highly valuable because really nobody wants that annoying developer who is very arrogant, who doesn't know how to deal with other people, who doesn't know how to communicate. So you need to be easygoing, right? And doesn't mean that you need to accept everything. When you have to confront, you confront. But the thing is that you need to be an easy person to work with, like a person who people enjoy working with. Because like if you have only that, your chances to keep the job are very high. Even if you don't correspond technically to the team, like if you are a nice person to work with, you're gonna keep the job in most cases. So like in your reviews, be nice with the other developer, like explain the concepts and do pair programming or mob programming remotely and give suggestions and, help as much as possible. So you need to have good English skills to write documentation or pull requests. And you need to know about the difference about cultures. Some cultures are more direct than the others. And you need to know that, for example, in cultures like a Russian person will be more direct, or a Dutch person will be more direct. And it's not because they are not polite, it's because it's their culture. So you need to understand that because, like, one behavior in one culture, like, if a person is very direct and blunt in Brazil, that's considered not polite. And you could have kind of a fight because of that. But when you're dealing with people from other countries and they have a different culture, you have to understand that some behaviors are normal in their culture. So you have to understand those differences. And difficult, right? There is a very good book called The Cultural Map. And if you want to work in an international company, I highly recommend this book. And then you're gonna learn more about that. But yeah, like you have to keep that in mind. Like when you're dealing with different cultures, there are different cultures, right? So you need to know how to handle, how to deal with them. Another skill that's very important is about clean code and refactor. And in this, like this ability is very important, right? Because we want to write the best code as possible because code is not written for the machine, it's written for other developers, right? So your code is a way to communicate as well. Because remember, you're communicating with other developers and even communicating with you in the future. Because if you have to maintain this code in 6 months, and if you did a good job in your code, it's going to be very easy to maintain the code. It doesn't mean that you need to put a crazy amount of time in the code. But with AI nowadays, it's easier than ever to create good code and refactor code, right? So this is very easy nowadays. There's no excuse, right? And by doing that, you become a different developer. You become a better developer because I still see many senior software engineers writing bad code, creating methods with 1,000 lines, like creating unit tests with 5,000 lines. It's ridiculous. Like code atrocities. They create code atrocities. And like we can't be software engineers like that. We need to write good code, nice code. Like use the principles like cohesion and low coupling. Make your code highly cohesive. Make your code do one thing very well and make your code with low coupling so that if you change one thing, it doesn't impact 1,000 classes. If you change one thing, it's okay because it's independent. So those foundational concepts of clean code are the most important. It's like the single responsibility principle from Solid. Right? Solid is very important. Once you understand Solid, your code will be a lot better. Communication in English, presenting and documenting tech clearly. So like these skills are very important. The more senior you become, the more important is for you to make a presentation and be able to influence your team and to be able to help them to be better software engineers. And regarding cloud and DevOps, and by the way, guys, for everyone here who stay until the end, I'm gonna give you the mind map. So we are almost finishing here, and we might still even have some time for questions if you have a question. So if you have a question, just think about it and you can ask me about your career, about anything you're going through in your career, and we can have a chat. And okay, so let's go. So you need to know about DevOps and automation. You need to know about Docker. Docker is very important. CI/CD pipelines like GitHub Actions. Like GitHub Actions, when I used it, I found it better than Jenkins because it's simpler. It's nice. Monitoring, so you need to know about monitoring. And the easiest tool to start is Prometheus and Grafana because they are free. Datadog. There is a way as well to have, as I remember, there was a way to have a free account, but it's not so straightforward. But you see what's best for you. You need to know about cost optimization strategies. DynamoDB is vastly used in the market. CloudWatch, X-Ray, IAM, and infrastructure as code. And Terraform is by far the most used infrastructure as code. And Kubernetes and like Helm, AWS Essentials for developers, Lambda, ECS, EKS, and Fargate. Regarding data and observability, we have SQL, NoSQL. So knowing about Postgres, MongoDB, and Cassandra will definitely help you. Streaming data, Kafka streams, and Flink. Observability, OpenTelemetry, Prometheus, and Grafana. We need to know about OWASP so that we know how to avoid security breaches. So just the basics. Obviously, you don't need to be a specialist in security, but you need to know at least the basics. Spring security, secret management, like obviously you can't put a password or any key that you can't share that is secret on your Git. So that's a big mistake. And instead of storing your passwords on GitHub, you store it on Vault or AWS Secret Manager. So if you do that, you're going to be fine. Data privacy. So you need to know about GDPR basics. Cap tiering, eventual consistency, service discovery, load balancing, circuit breaking, and resilience pattern. Regarding big data, you need to know about Spark, Flink in Java, Kafka at scale, data lakes. So, and as you could see, guys, there is a lot, right? There is a lot here. And I know that you addressed lots of technologies. And let me recap so that you remember what we addressed. So for foundations, we talked about Java, JVM, we talked about garbage collection, memory model, we talked about concurrency, the basic Java features. Those are the foundations. And also we briefly talked about algorithms and system design. And remember, if you want a job abroad, you need to be good in algorithms and system design. And by the way, in the Challenger Developer Mentorship, you can do mock interviews unlimitedly. You can do as many mock interviews as you want to get really good with interviews and ace them, right? And for modern trends, we talked about AI. For enterprise skills, we talked about Spring, Micronaut, Quarkus. We talked about many technologies. Professional engineering. So this is very important because, like I said, the programmer profession is that. Nobody cares anymore if you're a good programmer because nowadays a baby can code, right? A baby can create a prompt, a random prompt on AI, and a baby can create a whole application in 1 second. So really coding skills, like, okay, they are important, but not as important as it was a couple of years ago. So your ability to think about trade-offs, to think about architecture, to know how to solve the business problem, that's your core skill. That's what the companies value in you. So keep that in mind. Programmer skills is not valuable anymore because like I can create code in 1 second. Like in those days, I wanted like a very simple app. And like on my MacBook, there wasn't this kind of app. So basically I wanted to get all of the nodes from there is a note app here on the MacBook. And I wanted to get all of those nodes and merge all of them. And I was searching on the internet and there wasn't any program that I could basically all the text files and unite and concatenate all the strings in just one file. And I gave the instruction to AI. Like I said, AI, create a Java application that you concatenate all the information from all of those text files and put that in one file. And it created in 1 second. And I just run the Java application, and there you go. I had a full swing application that I could merge all of the texts, and I created that in 1 second. It was ridiculously easy. So that's why I'm telling you that the programmer's profession is dead. And to create that on my, like, without AI, it would take me a while. Like, I know it's easy, but I would have to write everything from scratch, and it would be different. But with AI, I literally took 1 second to create the whole application, and it solved my problem. So it's ridiculously easy nowadays. So yeah, it's just, it's just want you to understand this very important concept. You're not a programmer anymore. You're a software engineer. The companies don't care if you're a programmer. So forward-looking trends like AI, you need to know about a little bit about IoT. Well, IoT is a nice to have because really, in a job interview, you don't need to know about IoT. Soft skills are very important. You need to be a nice person to work with. Don't be arrogant, be humble, learn about communication, learn about communicating with other cultures. All of those things will help you to work in international project, right? You need to have good English skills as well. That will definitely help you a lot. Regarding cloud and DevOps, we talked about Docker, Kubernetes, GitHub Actions, monitoring tools such as Datadog and Prometheus, Grafana, and we talked about many things here, right? So those skills would definitely make you 10x more employable in 2025. So, and for you who stayed here until the end of this live, I'm gonna do what I always do. I'm gonna share you the form, right? So just a moment. So it's the satisfaction form, and basically you can give a feedback, and you also get the mind map so that you can study on your own. So that if you don't know what you study, there you go. I know it's a lot, but so what I recommend here, okay, Rafael, that's a lot. What do I do? My recommendation is that you create a personal project. Create a personal project with all those technologies we mentioned here, and particularly focus on Java, Spring, also AWS, containers. Use all of those technologies and use AI. If you can create an application with AI in, I don't know how many seconds, this is so quick. It's simply ridiculous how easy it is. And okay, so let me send the form here. Let me know if you can access the mind map as well, please. So if you do have a question, feel free to ask. You can write if you're too shy, or you can talk. It's up to you. If you don't have any questions, I think that's it.
Yes. Hi, Raphael.
Sure.
Yes. Hi.
Hello, Bender.
Sorry, I came in late. But if was there anything as far as how Java 25 would anything as far as because it looks like you have something about the forward-looking trends. So is that Java 25 is? I mean, how is Java 25 going to affect us and make us more employable?
Yeah. So I don't think that not knowing Java 25 will make you less employable, because it takes a while until the companies really use Java 25. Like not too long ago, the companies were still using Java 8. So it takes many years until the companies update their Java version to Java 25. So, okay, it's nice if you know Java 25. It's great. It will definitely put you ahead of the vast majority of Java developers, but it's not required. Like, for example, if you are weak with algorithms in system design, I would prioritize algorithms and system design instead, because that's what they ask you mostly in Java interviews. And like those are nice to have. So obviously, it always depends on your context. So if your focus is to get a job right now as a Java developer, you need to focus on the skills that they require in the interviews. So if they're asking, hey, Benjamin, like do a coding challenge, like studying Java 25 won't help you anything on that. So yeah, I don't know if I answered your question, but Java 25 is a nice to have. not necessary. Make sense?
Yes, you did. Yes, makes sense. Thanks. Yeah, the basics.
Yes. So basically, you need to understand what's your context in your career and understand, okay, what's the biggest bang for the buck? What's the technology? What are the concepts that will help me the most at this moment of my career? So those are important questions to ask yourself. Okay, so I will consider that's it for today. So challengers, congratulations for being here and being consistent to improve your career. And that's it. Like, your effort will pay off. Thank you so much. And hopefully we'll see you next week. Thank you so much, guys.
Bye.
Bye-bye.